Alright, so what we're going to do today is we're going to graph the polynomial. So we have f of x equals x cubed plus 3x squared minus x minus 3. And what makes this different from what we've done in the past is the fact that we have this stuff in the middle here. If I had given you f of x equals x cubed plus 3, we could say, well, that just takes the graph of x cubed and it translates it up 3. So that's just a shift, that's just a translation. Or if I gave you f of x equals x minus 2 cubed, we could say, well, that's a horizontal shift. It's going to go to the right too. The difference of here is it's not in that pretty format. We have the x squared, we have the x, we don't exactly know what's going on here. So there's going to be a few steps. I think it's a 3-4 step process. So the first thing we're going to do is we want to figure out what the big picture looks like. It's just like if anyone comes, we have every once in a while people come onto campus, they want to check our accreditations. They want to make sure we're doing everything that we're supposed to do so that all of our credits can transfer onto a 4-year university. Now when they come on campus, they don't want to know all the teeny tiny details. They don't want to come up to me and say, can you tell me every single student in every single one of your classes and how they're doing on every single assignment they've had. I have over 200 students this semester. I'm not going to sit down with them and say, well, student number 1, on homework assignment 1.1 they did this, at 1.2 they're going to do that, 1.3. We don't want to start with all the details because that would be insanity, right? So the first thing they do is they want to look at what are the goals for the college. What are we doing? That's the same thing we want to do here. What is the overall big picture? Where are we going? Where have we come from? So we want to look, first thing we want to do is we want to look at the end behavior. What is the end behavior of this graph doing? Because that's our big picture. So in the end behavior, what you're going to need to have memorized. You need to have memorized your basic shape of x squared and negative x squared. So the one we need to have memorized f of x equals x squared, which is a parabola facing up, and f of x equals negative x squared, which is a parabola facing down. The other thing you need to have memorized is your cubes. F of x equals x cubed. That's going to go into the double positive where x is positive and y is positive, and the double negative where x is negative and y is negative. So that's your x cubed. The other one you're going to need to have memorized is f of x equals negative x cubed. So that's going to be the reflection of that. It's going into the positive negative and the negative positives. Okay, that's how I call it. You could say it's going into whichever quadrant numbers it's going into. F of x equals x cubed is going into the first and the third quadrant. You could say it like that. I tell my students they could say it's going up to the right and down to the left for x cubed. That would be perfectly fine. I don't care how they describe it as long as they're describing it in a way that is correct. I do make my students answer in behavior in complete sentences. So I say for the given function, the end behavior would be going into quadrant whatever and whatever. The end behavior would be going into the double positive, the double negatives, the plus minuses, the minus plus. I don't really care how they format it. For the given function, the end behavior would be going whatever to the right and whatever to the left. Up or down to the right and up or down to the left. All of those would be complete sentences. I just need to make sure that by the time my students are graduating, whatever their boss wants them to write something about, write a sentence about, they can do it. Whatever their boss asks them to do, they can go, okay, I can do that and I can put it in writing. And if we can put math in writing, you should be able to put anything in writing. So that's why the math classes tend to focus on making sure we get those complete sentences. So in behavior, the way we're going to do that is we're going to look at the degree of the polynomial. When there is only one variable, the degree of the polynomial is going to be our highest exponent. So our highest exponent is 3. So the degree is 3. And you need to identify that degree if it is even or odd. 3 is an odd number because even numbers are divisible by 2 and 3 is not divisible evenly by 2. So it is an odd number. if your degree was even, it would be based off the general graph of x squared. If your degree is odd, it would be based off the general graph of x cubed. Even if it was 7, your degree is 7, it's going to be the general shape of x cubed, but there's going to be all sorts of chaos going on in the middle. So we can only use that for the end behavior. So once you find your degree, that's going to tell you if we're using this or this. Then I want to know the sign of the leading, that's an L, I don't know why I crossed my L, leading term. So whatever term your degree came from, is it positive, is it negative? Here it's positive. So what we're going to do is you have these 4 graphs memorized. You're looking for the one that has an odd degree and a positive leading term. The top 2 are both x squared, so they're even degrees. The bottom 2, there's your odd degree and your positive sign. If it was negative, it would be the general shape of x cubed. Or negative x cubed, sorry. Since it's positive and it's odd, we're going to have the end behavior is going to be the same as whatever the end behavior is here. So when you draw your end behavior out, I'm not going to draw the middle, because the middle could be, it's going to be all sorts of chaos because we have this x squared and this x. All I'm going to say is it's going to go up in the double positives, up to the right, first quadrant, sorry. And it's going to go down in the double negatives, down to the left, third quadrant, however you want to word it. That's your first step. What is the big picture? Where are we going? Where we come from? The next thing we want to look at, it's going to be our x-intercepts. X-intercepts, you're going to find, there's multiple ways you can do it. The one that should come the easiest to you should be factoring. You should be able to factor blindfolded with one arm behind your back. So we're going to factor this out. If it could not factor, you could not use quadratic formula because that only works when the degree is 2. You could use the rational zeros theorem and do synthetic division or long division. Would be your only other options, your main other options. Okay? But for here, this one can factor. So we are going to factor x cubed plus 3x squared minus x minus 3 equal to 0, because we want the zeros. Since it's 4 terms, we're going to do grouping. So we're going to group the first 2 together and find the GCF. It's x squared. If I take x squared away from x cubed, I have an x left over. 3x squared, take x squared away, I have a plus 3 left over. Then you're going to take your second group and do your GCF. They don't really have anything in common. But the GCF should always take whatever the first sign in the group is. So like here, the first one in the group was positive, so the GCF was positive. Here, the first one in the group is negative, so the GCF has to be a negative something. So we're going to take out a negative 1. So minus 1. Negative x, take away the negative, leaves you with just x. Negative 3, take away the negative, you're left with positive 3. Here you have the 2 sets of parentheses. If they're not the same, you did something wrong. More than likely, you picked a wrong GCF. It's 90% of the time what the mistake is. So here we're going to take out the parentheses since they're the same. I'm going to write one of them, just like I only wrote 1x squared, just like I only wrote 1 negative 1. And then I'm going to write down whatever's left, x squared minus 1. And when you factor, it is very important to do the very last step. The very last step is to look at every single set of parentheses and say, can it factor more? So x plus 3, it's 2 terms. That means it's either a formula, difference of squares, sum or difference of cubes. It has no squares, it has no cubes. Or it's GCF. It has no GCF. So this one cannot be factored. Here, it's 2 terms. That means it's either a formula or it's GCF. We do have a square, so it could be the difference of squares. So what I do for difference of squares, I set it up And I say x squared is what squared? X squared. 1 is what squared? 1 squared. And is it in fact a difference because the sum of cubes does not exist? So yes it is. So that one can be factored more. So this one's going to fall. X plus 3. X squared minus 1 squared, that's the difference of squares. A squared minus b squared should factor into a minus b, a plus b. So x minus 1, x plus 1, these all came from there, equals 0. And then to get our zeros, they're going to come from each set. X plus 3 equals 0, x would equal negative 3. X minus 1 equals 0, you'd add 1 to both sides, x would equal 1. And x plus 1 equals 0, you'd subtract 1 to each side, x would equal negative 1. Okay, so that's step 2 is the x-intercepts. Step 3 is going to be your multiplicities. So what we're going to do with the multiplicities, this is something that with the polynomials, when it hits a 0, there's one of two things that could happen. It could pass through the axis, going from the bottom to the top or the top to the bottom, or it could turn around, and that could be like the vertex of a parabola, or the bottom vertex of a parabola, the maximum or minimum, the relative maximum or minimums. So we need to figure out what it's doing at the 0 itself, because those are the details. The details that we want to worry about. We're not going to worry about all the little bitty details, but we're going to worry about the main details. So for the x-intercepts, for the multiplicities, I make a chart just because I like consistency. I like things to look the same every single time. If I don't make a chart, then every single time I write it a little bit differently. So the first thing I'm going to do is I'm going to have my zeros. Some of y'all may rather put x-intercepts. They are the same thing. Okay. I had x equals negative 3, x equals 1, and x equals negative 1. Those were my zeros. Then I want to know how many times was that 0 an answer? So if I look at these, they all appeared only once, right? None of them appeared twice or 3 times or 4 times. X equals negative 3, it only had one factor that came out to that. Positive 1 only came once, negative 1 only came once. So for here, it's all once, once, once. Okay? And I like to actually write that out, because that's emphasizing that we're not... It's emphasizing what we're focused on. We're not focused on what the number itself is. We're focused on how many times did it appear. For multiplicity, we want to know how many times did it appear. Okay? And then I want to know, is that number of times even or odd? I don't want to know if the 0 is even or odd. I don't care about the 0. That's just a spot in time. I want to know at that spot in time, how many times did it appear? All of them were once. For the number of times that it appeared, is that even or odd? So if it appeared once, 1 is an odd number. If it would have appeared twice, 2 is an even number. If it would have appeared 17 times, 17 is an odd number. That's what you want to focus on. It's not about what number's right here. We'll deal with that in the blue when we found the x-intercepts. For red, we're really focused on this is odd, because that is a 1. This is 1. That is odd. This, once is a 1. That is odd. And what we want to gain from this, the other thing you need to memorize, If your multiplicity is even, that means it turns around. If your multiplicity is odd, that means it passes straight through. So here, we're going to say odd multiplicities cross the axis. Even multiplicities turn around. And I'll explain a little bit more of that in a moment. All of ours are odd, so all of ours are going to cross through the axis. Okay? So step one, big picture. Where do we come from? Where are we going to? Step two, we want our current milestones. What are we currently working on at the moment? That's our x-intercepts. Step three, they're going to ask us, is there anything else we should know? What other information could we possibly get? That's going to be your y-intercept. And the example I keep going back to is like when people come to your job and they're coming, like the general manager's coming in, the boss is coming down. When I worked retail, we had the president of the company visit our store once. First thing they're going to ask, how are y'all doing? What are y'all planning on doing next? Where'd you come from? Where are you going to? Then they're going to say, what are the major projects you're working on right now? That's your x-intercepts. What are the major milestones? Then they're going to say, is there anything else you want me to know? That's going to be your y-intercept. That's what else are you working on? What's the only other thing we can get? Well, if I make x 0, I can get that extra ordered pair. Y-intercept is always when x is 0. So it's always going to be the number that doesn't have a variable. So my y-intercept is -3. So your step, I'm out of colors. Step 4 is the y-intercept. That's where you let x equals 0. So 0 cubed plus 3 times 0 squared minus 0 minus 3. 0, 0, 0, 0, -3. X is 0, y is -3. Okay? And then the last thing, we need to tie all this information up into a pretty bow to make it all look nice and fancy. When you present something at your job, you want it to look nice and pretty. I don't want to give them all this crazy math. I want to give them a pretty picture. So what I'm going to do, if I can find my markers, I'm going to put my graph over here, mainly because I have no room to put it anywhere else. So I'm going to make my graph. I am in no way, shape, or form an artist. My stick figures look kind of wonky. And I'm going to go back to the very beginning. I'm going to say, where do we come from? Where are we going to? So my end behavior should be going down on the left. So I'm going to say somewhere over here it should be going down. It should be going up on the right. I'm saying somewhere up here it should be going up. I'm not concerned about accuracy at that moment in time. At this moment in time, I'm just saying eventually we want to get somewhere in that general area. Right? If you're working on a 10-year goal, you're not going to say on October 5th, 2026, I am going to be doing exactly this. So much could happen between now and then. We have no idea what we're going to be doing or where we're going to be. So we are just looking at, okay, generalized should be somewhere in that area. Okay? Then we're going to go to step 2. That was your x-intercepts. I'm going to go ahead and put those on the graph. X equals -3. That is -3, 0. X equals 1. That is 1, 0. And x equals -1. -1, 0. I like to always label my ordered pairs. The more information labeled, the better it's going to be. So I put those on the graph. Then I look at my multiplicities. They were all odd. That meant every single time it was going to pass through. Okay? I can't do much with that until I get the line. So I'm going to skip to the only other piece of information I can put on the graph easily, and that's my y-intercept. So 0, -3. 0, -3 is going to go Now this next step is really going to depend on what class you're in and how specific of information your teacher wants. For my classes, I'm teaching entry-level college algebra. I'm more focused on can they get the highlights of everything than do they have every single little detail, every single relative min, every single relative max, all that stuff. That's for different classes. That will be more your pre-cal and your calculuses. But for my students, I want them to get the highlights. It's like when you're going into the job interview. You don't have time to tell them every single little detail about you. You've got to hit the highlights and make sure your picture shows your highlights. So what we have, my multiplicity says it should cross the axis at every 0, which means at this 0, -3, it should cross the axis. Now I know it's coming from below, right? So I'm just going to draw a little line that says it's kind of going this way. And then it's 0, negative, or -1, 0. That was also odd. It should cross the axis. Well, at this point, the line should be above somewhere, right? So it's going to be coming back down. Something like that. I'm not being overly specific. And then at the next 0, y-intercept's not a 0, only x-intercepts. 1, 0, still on, it's going to pass through again. Okay. And then I'm just going to go connect the dots. So from here, I know it should go down. Notice it does not have to go where my purple arrow said it was going to, where exactly it was going to go. It should go in that direction. We're on our way to that goal. Once it went up, I don't know how high it's going. Like I said, in my class, we're not quite hitting all the ins and outs of the relative maxes and relative mins. We're concerned, did you get the zeros? Did you know it went from down to up and then back down? So whether you take it to here, or to here, or to here, wherever that, me, and my college algebra class, am not overly concerned. Your teacher, if you have someone other than me, or if it's not my college algebra class, may care how high you take it, how exact it is. Okay? But I'm just trying to get the general picture. Keep in mind there should be some sort of symmetry most of the time. Then once it goes down, you know you're going to hit that y-intercept, so we've got to make sure we hit that. Turns around at nice pretty curves. And passes back through that 0 and goes on to infinity. Notice it's going in the same direction, but maybe it's not in the same place. These are not my answers. The actual line is. These are just saying, hey look, yay, we're going in the right direction. Awesome, great, good job. Okay? Your answer is that. Okay? So anytime you're told to graph a polynomial and there's chaos in the middle, start by determining your end behavior. Where is it going to go? Hit your major milestones. What are your zeros? What are your x-intercepts? What happened at those places? Anytime you're telling your major milestones, well, this was my first job and my second job and my third job. They're like, awesome, what happened at those places? Well, I did this and this and this. I did that and that and that. I did this and that. Okay, so what happened? That's your multiplicities. What else do we need to know? Let me get at least one other point off of the x-axis. Give me where it crosses the y-axis, because that's not a hard number to find. And then put all of that information on the graph. Okay. So how to graph polynomials of higher degrees.